Good morning, good afternoon, good evening. This is Mr. Payne bringing you Unit 8, Lesson 5, Stretching Parabolas and More Completing the Square. Objective: you will have mastered what different a values do to a quadratic and will be able to complete the square with a lead coefficient other than 1. Exercise number 1. Let's understand what a really does in y equals ax squared plus bx plus c. So far we know that if a positive a, the parabola opens upward, and if a is negative, it opens downward. Let's see if we can deepen our understanding. Using your calculator, sketch a graph of y equals x squared, y equals 2x squared, and y equals 4x squared on the axes below. Use the window to indicate the axes. Label each with this equation. What I'm going to do for you right now is I'm going to label the three of them. The first one I'm going to label gray. And that's my y equals x squared. Each one of these should go through the axes. The second one, 2x squared, is going to get a little thinner or a little steeper. And then 4x squared in orange is going to be the one that is the steepest out of all of them, or the most narrow. Explain what is happening when multiply x squared by a. Well, the bigger your a, the steeper you get or the narrower you get. So let's write that in. It gets steeper. The same thing happens when it gets to be negative. The negative just flips it upside down, okay, and it gets steeper the same as well. I want to just show you, and there is no example for this, but what I want to show you is if it's less than 1. So if that a is less than 1, let's say 3/4, it's going to start going the other way. 1/4 would obviously be even farther out. It would be getting fatter or wider. I know those examples aren't on there, but I wanted to give them to you anyways. Gaining a deeper understanding by matching. Exercise 2, the graph below shows curves that are listed. Write the number of the equation in each besides its curve. So all you're doing is taking this one here and deciding which curve it goes with. And I want you to put the little 1 up here or here or here. That's all you have to do. Do this, and I will check this, and this is where we'll be starting in class. Since all quadratics of the form y equals ax squared have their turning points at the origin, we can also identify turning points if we can place a quadratic in vertex form even if a doesn't equal 1. This is harder mechanically. Consider the quadratic y equals 2x squared minus 12x plus 11. Use the method of completing the square to write this equation in the vertex form. So the very first thing that I would like to do is rewrite the problem. 2x squared minus 12x plus 11. The first thing I need to do is pull a GCF out of the first two. I would like to pull the GCF out of the first two. So out of here and here, what is my GCF? I hope you told me that my GCF is 2. So I'm going to pull that 2 out front. And then I'm going to divide by 2, don't forget. So I'm going to be left inside my parenthesis with x squared minus 12x, or minus 6x. And I want to go ahead and take that plus 11, and I want to slide it way over here. You should have a nice gap right here. We're going to fill that gap in a moment. Off to the side, I would like you to figure out what my c is going to be. So that means I have to, if you remember from yesterday, I take my b, which is 6, I divide it by 2, and I square it. So 6 divided by 2 is 3. 3 squared is 9. So I'm going to plug that plus 9 in right there. But we have to be careful. And I'm going to put this in a blue. Actually, I'm going to put this in a different color. I'm going to put it in red again. What did I really add to that equation? I have to remember that I pulled 2 out because it was my GCF. So I really added 18. So I'm going to put that really small, positive 18, right here, because that's what I really added. I really added 18. So if I added 18 to that equation, what do I have to subtract from the equation? I have to subtract 18. This is a tough concept. This piece right here, and I'm going to circle it in yellow so that you know that's a tough piece. And I really encourage you to write what you added up into the corner like that so that you know what you have to subtract. Now let's go ahead and just factor it. My 2 is going to stay out front. I'll get a better color for you. My 2 is going to stay out front. And now I'm going to go ahead and factor it. I'm going to have x minus 3, x minus 3. Negative 18 plus 11 gives me negative 7. Don't forget that this here can be simplified. My answer is going to be 2 times x minus 3 squared minus 7. B says, what are the coordinates of the turning point of this quadratic based on A? Provide evidence from a calculator table that supports your answer. My vertex is still going to come from the same area. Those 2 points, or those 2 pieces, will give me my vertex. So therefore, my vertex is going to be positive 3, comma, negative 7. Remember, this guy is the opposite, because he's inside. This 2 out front just tells me that my quadratic will be a little steeper than normal. Completing the square when the leading coefficient doesn't equal 1 is much more difficult to master and understand. Always remember that you are writing an equivalent expression by essentially adding 0 in one way or another. Exercise number 4. Use the method of completing the square to write each of the following quadratic functions in vertex form. Y equals a times x minus h squared plus k. Identify the turning point of the quadratic from this form. State whether it is a maximum or a minimum. All right, let's try out A. I'm going to go ahead and get started right where it sits. I'm going to pull out my GCF of 5x squared and 20x. My GCF there is going to give me 5. So I'm going to divide by 5, put 5 out in front. And I'm going to slide that positive 23 way off to the side here for a second. So I'm going to be left with x squared plus 4x. In red, I'm going to go up front to find what my c is. So my b is 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. So I'm going to put a plus 4 in here. But what did I really add? And I'll put this in lime green. What did I really add? I really added 20. So if I really added 20, I have to subtract 20. Remember, how did I get that 20? I said 5 times 4 gave me 20. So you can't forget that step. If I added 20, the opposite of adding 20 is minus 20, because that's my 0 part right there in green. Now let's go ahead and factor this. 5 goes out front. And I'm going to have x plus 2 squared plus 3. Remember, we're getting good enough now that I don't have to write x plus 2 times x plus 2. We know that it's x plus 2 squared plus 3. So, what is my vertex? My vertex is negative 2, 3. And I'm going to have a minimum. How do I know that it's a minimum? I know that it's a minimum because this guy here is a positive 5. All right, let's go to B. I'm trying to pick some different colors to write in each time. All right, my GCF here is negative 2, so I'm going to divide by negative 2. Put negative 2 out in front of my parentheses. I'm going to have left x squared minus 2x. And I'm going to put that plus 7 way outside here. In red, I'm going to figure out what my B or my C is going to be. So I take my 2, I divide it by 2, and then I square it. 2 divided by 2 is 1. 1 squared is a positive 1. What did I really add, though? Negative 2 times 1 is negative 2. So if I really add a negative 2, the opposite of that to make that a 0 pair is I have to add 2. Once again, you notice how this is making it 0. Now let's go ahead and factor it. Negative 2 goes out front. X minus 1 squared plus 9. My vertex is going to be a positive 1, comma, 9. And it's going to be a max. How did I know it's going to be a max? This negative 2. This negative sign tells me it's going to open downward, so therefore my vertex is going to be a max. All right, let's take a look at C. When I say that I'm going to pull my GCF, I'm really just talking about my term in front, my coefficient term. So between 6 and 24, my GCF there is 6. I don't want to pull the variables, so make sure we're not pulling the variables. If I divide by 6 then, what am I left with is x squared minus 4x. Let's go in red. Find my B or my C real quick. So my B is 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. So it's plus 4. What did I really add, though? 6 times 4 is 24. So I really added a 24. So if I really added a positive 24, what do I have to subtract? Negative 24. So let's go ahead and factor. I'm going to have 6 times x minus 2 squared minus 10. What's my vertex? My vertex is going to be a positive 2, comma, negative 10. Because this guy is positive, that means I'm going to have a minimum. D. Be careful here. What is going to be my GCF? My GCF is going to be negative 1. So I'm going to divide by a negative 1, divide by a negative 1, put negative 1 out in front of my parenthesis. I'm going to be left with x squared plus 12x. Put that negative 33 way outside here. Take my b in red. I'm going to have 12 divided by 2 squared. 12 divided by 2 is 6. 6 squared is 36. So I'm going to add 36 here. But what did I really add? Negative 1 times 36, I really added a negative 36. So if I really added a negative 36, what do I have to put in there to make that a 0? A positive 36. I really like how I'm color coding this, and I'm hoping that it helps. So I'm going to go ahead and factor now. Negative 1, parenthesis, x, plus 6 squared, plus 3. My vertex is going to be negative 6, comma 3. Because my a out here and here is negative, that means I'm going to have a max. I hope that your understanding is a little bit better of completing the square. We did practice it. There is 1 or 2 extra steps. We will continue to practice this for 2 days. Make sure that you write down any tricky points or any rules and steps that you would like. I will hand out rule cards on tomorrow. But if you have any questions, please jot them down so you know what to ask when we get into class.